Welcome to today's tutorial. We are going to talk about analog value processing, specifically focusing on the input side. Analog is a broad topic, so in this video, we will keep our attention on analog inputs. Let me explain what we are working with. We have a tank on our HMI display, and we want to show the fill level of that tank. The range we want is 0 liters at the bottom and 20 liters at the top. Everything in between is a linear scale. That is our goal, a simple clean fill level display in liters. Now let us look at how this works inside the PLC. Step 1, configuring the analog input module. The first place we need to go is the device configuration in TIA portal. Here you will find your analog input module. Select it, then go to Properties, and look for something called Channel Template or Analog Input Processing. The exact name may vary depending on your TIA portal version, but it will be somewhere in that list. Under the Input section, you will find a few important settings. First, there is a diagnostics option for overflow and underflow. This simply means that if the signal goes outside a configured range, the PLC will trigger a warning. You can use that warning in your program logic if needed. The more important section is the measuring part. Here you can choose whether the module measures voltage or current. For voltage, common options are 0 to 10 volts, 0 to 5 volts, 1 to 5 volts, or plus minus 10 volts. The most common voltage standard in industry is 0 to 10 volts. For current, you have options of 0 to 20 milliamps, 4 to 20 milliamps, or plus minus 20 milliamps. The most common current standard in industry is 4 to 20 milliamps. We will use 4 to 20 milliamps for this tutorial. So in our example, when the tank has 0 liters, the sensor sends out 4 milliamps. When the tank has 20 liters, the sensor sends out 20 milliamps. You might wonder why we start at 4 milliamps and not 0. The reason is wire break detection. If the current drops to 3 milliamps, 2 milliamps, or 0 milliamps, it means the sensor or its wiring is broken. This is called wire break diagnostics, and it is one of the key advantages of using the 4 to 20 milliamp standard. You can enable this option in the Properties panel. Since we are working in simulation, we will leave it off for now. Step 2, understanding smoothing. The last setting to note is called smoothing. When a sensor sends an analog signal, it can sometimes pick up external interference, such as noise from a nearby motor or a mobile phone. This creates unwanted spikes in the signal. Smoothing filters out these disturbances by making the signal slightly slower, but much more stable and accurate. You can choose between none, weak, medium, and strong. A weak smoothing setting is usually a good balance for the most applications. Step 3, understanding the raw PLC value. Once you have configured the module, here is what actually happens inside the PLC. The analog input module takes the physical signal from the sensor and converts it into an integer value. The minimum value, which corresponds to 4 milliamps or 0 liters, becomes 0. The maximum value, which corresponds to 20 milliamps or 20 liters, becomes 27,648. This number is always the same for Siemens analog input modules regardless of the resolution. It is a standardized value built into how the module works. You will find it in the TIA portal information system and across all Siemens documentation. So what the PLC actually holds is not 20 liters. It holds a raw integer between 0 and 27,648. Our job is to convert that number into something meaningful for the human operator. Step 4, analog processing in the program. We will now create a function block called analog processing to handle this conversion. This function has the following interface: input, the raw analog input value, which is an integer ranging from 0 to 27,648. Output 1, fill level in liters, which is a real number. Output 2, fill level in percent, which is also a real number. Inside this function, we apply two operations in sequence. Operation 1, normalize. The first step is to normalize the raw value using the normx instruction, which you can find under conversion functions in TIA portal. Normalization takes our raw integer input and scales it to a value between 0 and 1. The minimum input is 0, the maximum input is 27,648. And the output is a real number between 0 and 1. So if the tank is full, the normalized output will be 1. If the tank is half full, the output will be 0.5. If the tank is empty, the output will be 0. This gives us our fill level in percent as a decimal value. 0 means 0%, 1 means 100%. Operation 2, scale. The second step is to scale the normalized value into our desired physical range using the scale x instruction. Here we take the normalized output, which is between 0 and 1, and map it to our actual range of 0 to 20 liters. The minimum value is 0.0, the maximum value is 1.0 on the input side, and on the output side, we set 0.0 as the lower limit and 20.0 as the upper limit. The result is our fill level in liters as a real number, which goes directly to our HMI display. Now that we have built our analog processing function block, the next step is to call it from the organization block, which is our main cyclic program. Inside the organization block, we drag in our analog processing function block and assign the inputs and outputs. For the input, we connect the raw analog integer value. For the outputs, we connect our fill level in liters, which will be sent to the tank level screen on the HMI. In a real industrial setup, the input would come directly from the analog input card installed in the PLC rack. That analog input card would be wired to a level transmitter mounted on the physical tank. The level transmitter continuously measures the liquid level and sends a 4 to 20 milliamp signal back to the analog input card. The PLC then reads that signal as our raw integer value between 0 and 27,648. The processed output, meaning the fill level in liters, would then be displayed on the tank level screen of the HMI for the operator to monitor in real time. Since we do not have a physical level transmitter in this tutorial, we are simulating it. I have created a data block and assigned a start value of 10,000 to the analog input tag inside it. This value of 10,000 acts as our simulated level transmitter signal. It sits within the valid range of 0 to 27,648, so the normalization and scaling will process it correctly and display the corresponding fill level on the tank level screen. This approach allows us to demonstrate the complete analog input processing workflow without any physical hardware. Recap. Let us quickly summarize what we covered today. First, configure your analog input module in device configuration. Set the correct measurement type and range for your sensor. In our case, that is 4 to 20 milliamps. Second, understand the raw PLC value. The module always converts the physical signal to an integer between 0 and 27,648. 0 corresponds to the minimum physical value, and 27,648 corresponds to the maximum. Third, in your program, use normx to normalize the raw value to a range between 0 and 1. Fourth, use scale x to scale that normalized value to your actual physical range, such as 0 to 20 liters. That is the complete analog input processing workflow in TIA Portal. If you have any questions, drop them in the comments below. I am happy to help. Thank you for watching, and I will see you in the next video.